Hello, everyone, and welcome to this joint webinar organized by Confluent, HashiCorp, and Bitrock. My name is Alfredo Zanardi, and I will be moderating this webinar, which will analyze a use case created by one of Bitrock's DevOps engineers on how to handle Kafka records erasure in compliance with GDPR data retention limits, leveraging one of HashiCorp's solutions, Vault. I have the pleasure to host this webinar together with Ugo Landini, Senior Solution Engineer at Confluent, Narayan Yengard, Product Manager, Vault Ecosystem at HashiCorp, and my colleague, Simone Ripamonti, DevOps Engineer at Bitrock. This webinar is divided in 3 sections of 15 minutes each, where we will have the chance to listen to each speaker and the Q&A session at the end. Feel free to post your questions in the Q&A section during the event. We will answer to them at the end of the webinar. The first section is with Ugo Landini, Senior Solution Engineer at Confluent. Ugo, the floor is yours.
Yeah, thank you, Alfredo. Ciao, hello, hi everyone. So this is Ugo Landini speaking. As Alfredo said, I'm a Senior Solutions Engineer in Confluent. I live in Italy, Rome, Europe. So today, I have to say that I'm very pleased to be here together with Bitrock and HashiCorp. So thank you again, Alfredo, everyone. Because today we will talk a bit about this nice, let's say, joint solution about GDPR. And I think it's a really interesting one. It's a really interesting solution because for once, it's a real use case, something tricky that could be easily done wrong. It's something that could look easy, for a customer, but it's not. So I think it's pretty interesting to have this solution ready, presented for you guys. Personally, I think that this solution really rocks. So let's start. I will just briefly introduce Confluent. What we do to make enterprise Kafka mostly, how that's different from Apache Kafka, the community one. We'll also have a very high-level overview of the security features of Confluent, so to introduce nicely the other speakers. So next slide, please. So what's an event? An event, so let's talk about this event streaming thing a bit. So an event is just something that's happening. So it's just a piece of information, a piece of data, let's say, with a timestamp, basically. So not much more than that. Event streaming means receiving, storing, managing, messaging, analyzing. So a huge amount of these events in real time or near real time. When I say huge, I really mean it, because we have customers doing gigabytes per second of traffic. So it's something that's definitely not easy to achieve with other technology. Let's talk a bit about how disruptive this concept of event string is. So let's talk a bit about software defined. So this is a transformation, and it's for real. It's not just happening anymore only at Silicon Valley. It's everywhere. So the biggest enterprise in the world, across every industry, everyone is on a journey to become software defined. So it's happening in automotive, transportation, banks, retailers. So it's everywhere. We have a lot of customers across every industry. And so next slide, as you can see, Gartner say that by 2020, real-time situational awareness will be required characteristic for 80% of digital business solution. So it's really something interesting for everyone. It's across, let's say, every industry. So next slide. How organizations see the requirements for this data platform to become software defined. So it's basically four different requirements. First, the platform needs to be built not for historical data, but for real-time events. And we define what's an event before also, not in a very formal way, but that's not much more than that. For example, if you are, you don't have to analyze how many, I don't know, books were sold last weeks, but you have to trigger real-time event when every time a book is sold. So you can make a lot of things happening in real time, no? Such as the level of the inventory dropping and triggering stuff, starting the shipment process and all these kind of things. So it's important not to design the thing to be built for events. So it's a different thing. Second, the scalability is important, no? Because it's, as I said, we have customers doing a lot of traffic, and it's not only transactional data, it's also logs, IoT, security events. So it could be really a lot of stuff. The third thing is the platform needs to be persistent, durable. Not one, no, where data is transient and vanished after going from point to another. So this is because mission critical apps require zero data loss, and sometimes you need to replay things in case of an error, no, or missing data. So it's important to be persistent, not transient. And the other thing is about the messaging of the data, basically, no, enriching data. So it's not just for the raw data, but you have to be able to add things on the data, metadata, aggregate things using slices, windows. So there are a lot of things that you can do, no, in real time. So it's important. Next slide, please. So this is basically the event streaming, no? A new data platform, which is built from the ground up to become software defined. So it's not only databases, it's not only messaging, it's not only ETL, it's not only the data warehouse. So it's something that can do all the things together, basically. So it's next slide, please, because there should be an animation here. Okay. Oh, we just skip the animation, but it's the same. So basically, the point is that a lot of companies are doing this, so it's pretty much important not to have something enterprise to manage all this traffic, this data together, make it persistent, and being able to analyze this data in real time. So let's see, next slide. Let's see briefly the Confluent platform. Next. So, okay, blah, blah, blah. We have a lot of customer. Go on the next. Yeah, perfect. So this is the Confluent platform. As you can see, there are a lot of different things that we add on top of the basic community Apache Kafka. So very fast, we have support for multi-language development. So not only Java and not only Scala. So different things. We have a pre-built ecosystem for connectors. We have the schema registry if you want to manage the metadata about the data, the schemas. So we have the event streaming part, which we call KSQLDB. We have also all the operator part, the graphical user interface, the operator to install on Kubernetes, Ansible. We can do dynamic performance with the auto data balancing cluster. We have tiered storage. So a lot of things, multi-region cluster, replication, cluster linking, schema validation. So today will be just, we will see just the security part, no, because it's important to have an introduction for the GDPR use case to the airbag, the secrets, and the audit logs. So next slide. Enterprise grade security. Okay, so these are all the, you see on the left, there are the customer goals. So how to ensure confidentiality and compliance, how to enable granular access to critical resources, how to simplify the operation, and how to standardize security across the platform. So these are all the different features that we have. No, there is the TLS encryption, the secret protection, the structure, the audit logs, SSL authentication, Kafka ACL, airbag, and you see, there are different things in different colors. That's because some of the things are just part of Apache, of the community, so they are open source. Some of them are under a different license from Confluent. It's open source, but it's a community license. And then there are the, I don't know how to say the name of that color. So it's like, you know, I don't know, a mix. I see that like a mix between orange and brown. So those are the commercial things, no? Secret protection, the audit logs, and the airbag. So next slide. Okay, so the first goal is to ensure confidentiality and compliance. So let's start with confidentiality first. The first thing to know here is that data in Kafka is stored in plain text. So this includes highly sensitive information or user password. So the password to a database, for example, not like Mongo or other things. So the secret thing is interesting here because it is like a stripped down version of what HashiCorp Vault can do. So it's just for password. It's not something much more powerful, but it can be used to just hide the password. And I think it's important because it's secret protection. You can do that with JSON file. You can do that with inline Java authentication and authorization service. So I think it's pretty much important, no, to highlight this feature. No, as you can see here, you have password exposed in plain text on the top, and down then there is the secreted, let's say, version of the file. Next. So let's look at the concept of ensuring compliance. So this is audit logs, and it's something that a lot of customers ask to us. So it's a feature that we recently added. So it's basically security-related monitoring, regulatory compliance. So something that is not in open source Kafka. So here you have a special audit log or a special audit topic with all these logs inside, everything that's happened, like an authorized event, a create topic event, a produce event. It's kept in a topic, obviously, as everything else in Kafka. Use a standard which is called cloud events to define the syntax of the log, which is just JSON on steroids, basically. And so basically you have this audit log, and you can see whatever it happened on your cluster, and you can respond to this regulatory compliance. So it's pretty much important for a lot of customers. Next slide. And I think this is the most important thing, basically, because it's not very useful to have audit logs if you cannot see who did what. So that's the second customer goal, no? Enable granular access to critical resources. So there are two main challenges here with open source Kafka. So no way to connect to existing authorization system, like, I don't know, Active Directory or an LDAP. And there is no concept of multi-tenancy. So here with Confluent, we have this centralized airbag thing, which is pretty much everything you can imagine. So a DLDAP authorizer, predefined role, granular permission, and this is consistent. Basically, it works on Kafka, on Connect, on KSQL. So all the pieces of the Confluent platform are working together with airbag. So it's really important. Let's see next slide. So you can do that from the graphical user interface. So you can there are access control lists that are present in the Apache Kafka, no? But that's if you can get very complex when trying to map hundreds or thousands of users to individual ACLs. So by enabling the creation of resource owner roles with Confluent, no, you can allow Kafka administrator to delegate the responsibility of managing access permission to true resource owners, such as, I don't know, a department or a business unit, something like that. So this helps the customers, the organization, to scale Kafka more efficiently because it spreads the load of managing authorization across a variety of users. So it's easier. And this is done in a centralized way. So it's much better than basic ACL. And as I said, next slide, this is enforced via all user interface. So the graphical user interface, the CLI, but also the API, and across all the components. So the control center, Kafka Connect, KSQLDB, schema registry, the REST proxy. So everything is working as expected. So you cannot do something that you are not allowed to. I think this is pretty much it. I don't know if I was in time. And so let's give the virtual microphone to Narayan. And thank you.
Hey, thank you, Ugo. Excited to be here. And as Alfredo and Ugo pointed out, that this has been a great partnership between HashiCorp, Bitrock, and Confluent. My name is Narayan Iyengar. I am a product manager on the Vault team. My primary goal is to work with our ecosystem partners, such as Confluent, such as Bitrock, and provide new and exciting workflows, or enable new and exciting workflows for our customers and our practitioners. Next slide, please. So I wanted to kind of give you a very high-level overview of what HashiCorp Vault is. If you're not already familiar, Vault is primarily started off as a secrets management solution, a centralized secrets management solution. And as Ugo pointed out, there's this journey that enterprises are doing from on-premise to the cloud. But in this journey, there are a lot of things that have the ability to go wrong. So one of the main things that we've noticed is secrets. There's a secret sprawl. There's an authentication and authorization issue, as Ugo was pointing out. Enterprises need fine-grained access control to say only certain people have access to certain resources, and this is especially useful or critical in Europe with GDPR, like strict GDPR regulations. So the way Vault works today is you have an authentication mechanism, and a user or a machine or a service or an application would authenticate using its identity, using one of several authentication mechanisms. And as soon as that machine or the user or the service is authenticated, it is handed a token which is associated with fine-grained policies. And this policy gives access to a lot of Vault's backend. And these backends could be the ability to generate secrets for a database, the ability to encrypt or decrypt some data using the what we call the transits backend, or the encryption as a service backend. Next slide, please. So Vault's use cases have expanded significantly since just secrets management. Vault can be considered as a security platform that not only provides secrets management, but it can provide encryption as a service. It can provide identity-based access, and it can allow for some pretty advanced data protection. This is not data that typically Vault would store. Vault would, necessarily, just like encryption as a service, Vault will allow you to encrypt data at very high speed and then store it in your systems of record, such as databases or S3 buckets or anything like that. So next slide, please. As I said, what is Vault's vision? To be a global platform for data security in general. It doesn't matter in Vault in general. We want to assist our enterprises as they're moving from on-premise into cloud and multi-cloud. And once they get into the cloud and they start using cloud-native services such as Kubernetes or containers, or you go even further and start using serverless functions, Vault aims to provide a centralized orchestration mechanism for not only secrets management, but for lots of security workflows. Here you can see encryption as a service listed. Some of the more enterprise features, such as KMIP and full disk encryption and transparent data encryption, things like tokenization and transformation are available for our enterprise customers. And just as Hugo pointed out, a lot of our core security primitives are available in open source. A lot of our secrets management engines are available. Actually, all of our secrets management engines are available open source. So one of the key things for Vault is, how do I do dynamic credentials for databases so that credentials are not left, static credentials, long-lived credentials are not left in some database or in some GitHub repository. Vault will generate very short-lived credentials. All of those things are open source. Encryption as a service using our transit backend that Simone will demonstrate today, that is also open source. So Vault, as a team, we fundamentally believe being good stewards of the security industry. Where we see a lot of enterprises facing challenges are similar to what Hugo was pointing out with Confluent, is audit logging and scale and compliance, and that's where the enterprise features of Vault will fit in. Next slide, please. Yeah, so I briefly touched on some of the use cases of Vault. There's a lot of use cases. Vault is specifically designed to be very pluggable and very expandable. Vault is considered like the Swiss Army knife of data protection. So we are surprised as to how our open source community and our practitioners and our partners are using Vault and fitting it into various different workflows. And it's amazing to see. One of the use cases that we'll cover today is data protection, right? How do you protect data with a centralized key management solution? Cryptography is hard. It's expensive to deploy all of these things. It's expensive to learn cryptography, and more so, it's easy to make mistakes in terms of not picking the right key, not picking the right type of cryptography for your particular platform. And this is the challenge that Vault aims to solve. The next slide, please. It provides this centralized key management and encryption service via the transit engine, as I said. And Vault can also pair with an HSM if you have requirements such as FIPS. But Vault can allow you to reduce costs by not having to deploy, lots and lots of HSMs, but have just a few HSMs, but centralize your key management and your encryption workflows. And the next slide, please. One of the key, as I mentioned, cryptography can be very hard to deploy and manage, but Vault's aim is to eliminate that complexity and the need for operators and developers to be cryptography experts. Vault is specifically designed to be simple to use, but if you open up Vault and start learning about Vault and how it's structured, it's very complex of a product. But on purpose, Vault is built to be very API driven, very simple to use, and as Simone will demonstrate today, it is very easy to plug into different platforms like Confluent, who have a very clean interface. And next slide, please. Yeah, and this kind of just gives you a very brief overview of how the transit engine might work. You can automate encryption and decryption using APIs. You could centralize key management. Vault will not store this encrypted data or the decrypted data. What Vault does is it centrally manages the key and the key life cycle of that key. So if you want to rotate a key or revoke a key, let's say you see that you notice that based on your audit logging that the key has been compromised, that or the key has not been rotated for 90 days, and the company mandate is to rotate the key every 90 days. You can set up Vault to automatically go do that. Vault will rotate the key, let you know that the key has been rotated. Vault has very robust audit logging capabilities. We have recently partnered with Splunk. We have very good integrations with Datadog and obviously Confluent to tell you what is going on, who accessed Vault, who did what at what time. Similar to what the challenges that our joint customers, like Google's customers and Vault's customers, are facing in terms of compliance. Right? And that's basically, I wanted to set the stage and kind of, I believe this is the last slide. Next slide, please. And the ability to reduce risk, to reduce your attack surface. You want to be able to increase the cadence with which developers can use cryptography and do key management without having to learn the concepts of cryptography, which can be very, very complex. And you want to be able to reduce cost. Vault is available open source. Vault is a binary. Vault can run pretty much anywhere Go can run. I run Vault on my Raspberry Pi clusters at home. And it is extremely simple to get started. If you go to vaultproject.io, there's excellent documentation on how to get started with Vault. And it basically, the core tenet is simple to use, API driven, but extremely secure, centralized data protection services. So next slide, please. I wanted to, kind of hand the reins over to Simone, who's gonna see how, show you how Confluent and Vault work together to provide, data retention and erasure capabilities for GDPR compliance. Thank you.
Thank you, Narayan. Thank you, Hugo, for introducing Vault and Confluent. So I'm Simone Ripomonti. I'm a DevOps engineer at Bitrock, and today I will talk to you about a particular use case related to Kafka records erasure. Next slide, please. So let's start with a simple question. How do you delete Kafka messages? Well, stay with me for a couple more minutes and I'll tell you. Next slide.
I can answer, Simone, if you want.
No spoiler. Next slide, please. So let's start. Why should we delete Kafka messages? Well, for example, if we need to comply to regulations. Confluent Platform and Kafka have become the central data hub for modern organization with heterogeneous data coming from all the company departments. So over the year, many use cases arose, including those that are related to handling sensitive data. And when dealing with sensitive data, given that we are in the UE, in the European Union mostly, we need to comply to the right to be forgotten, for example, or we may comply to data retention limits by the GDPR. Often this translates in the need to delete user-sensitive data upon request. And in Kafka, you might not be able to directly delete a set of messages, but I'm going to show you a way to do that using Vault. Next slide, please. So in Kafka, there are mostly two ways to delete messages. The first one is when we have a retention-based topic. And so we need to wait for that retention to expire. So for example, if we have a topic configured to hold the data for 1 month, the oldest data will disappear only after 1 month. And this might not comply to the desired time of data retention, but still we cannot change the topic retention, otherwise we will mess up with the business logic. The second way is instead of using a compacted topic, which support writing tombstone messages, which will delete all the messages with a given key. Still, this might not fit all the use cases because a compacted topic fits only a certain set of use cases indeed. Next slide, please. So the idea is, what if I encrypt the messages and then I delete the key? So if the message is encrypted, but I no longer have the key, then the message content is lost. And so I'm complying with the regulation. So an example flow can be, well, the user registers to my website and I create an encryption key for him. So when the producer is going to write some data to Kafka, this data is encrypted with the user key and stored as a ciphertext in Kafka. And when the consumer is going to read the data, it is first decrypted using the same encryption key. And so the consumer is able to process the data. When the key is deleted, this flow no longer works, in the sense that when the consumer gets the ciphertext from Kafka, it will be no longer able to decrypt the data, and so we are not able to process that. So, okay, we are talking about keys, yeah. So we need to manage them in a smooth way. Next slide, please. So there are two ways. The first one is a naive approach. So we do that by hand, in the sense that we build our own key store implementation, but it is error prone, it's time consuming, and we need to be sure that the keys are held in a safe place. The second approach is a smarter one, and it is using a ready solution like HashiCorp Vault and the Transit Secret Engine that is open source, easy to set up, and really easy to get started with, because, as Narayan said, it has a full-fledged set of HTTP API that will ease the execution of cryptographic operation on your side. Next slide, please. So our first approach is to fully use the Vault Transit encryption capabilities, in the sense that we use the key management by Vault, and we also run a server-side cryptographic operation like the encryption and decryption on the Vault side by simply doing some HTTP requests. So what happens is that we build an interceptor that is a particular piece of architecture in Kafka that is placed on the client side, which means that when the producer is writing some messages, these messages are intercepted by the interceptor, which on the behalf of the client will encrypt the messages and then will write them encrypted in Kafka. On the other hand, when the consumer wants to read some messages from Kafka, when they are returned from the broker, the interceptor will decrypt them with the appropriate key retrieved from Vault. And the client-side application will receive the plain text data if the key exists. Next slide, please. This is a really simple solution to implement, but it has some drawbacks. In particular, given that we are running a streaming platform like Kafka that has been designed to held thousands of messages per second per client, introducing one HTTP request per message that is being read or written generates a too big overhead. And this overhead is shown in these two graphs that show some data obtained by running the Kafka consumer perf and Kafka producer perf performance tests. And we simply show that the degree of magnitude that of performance degradation in this case is simply too much to hold. But this is not trash, because the solution fits perfectly some different architectures. For example, let's assume that we want to encrypt the data for users that are registering to our website before storing them on a relational DB, for example. If we simply add a couple of milliseconds in the first registration request, probably the final user will not even notice that there is this delay introduced. And in particular, this solution is really easy to get started with, and almost no effort required. It's just a matter of running a couple of HTTP requests and you are done. You don't need to know cryptography at all. Next slide, please. What we are going to do as a second iteration is try to overcome the limitation of the HTTP request. And this is done by thinking, what if we just use a Vault Transit for key management and not for performing the cryptographic operation? This will expose the keys on the client side, but will give us more flexibility in terms of the number of HTTP requests that we are going to execute. As an example, when the producer will try to write some data to Kafka, the interceptor now will just retrieve the encryption key and will perform the cryptographic operation locally. In the same way, the consumer will decrypt the encrypted payload locally instead of sending the payload to Vault. Next slide, please. And this proved to give a really interesting performance boost. In particular, we introduced a time to live based cache for the keys, so that we reduced to the minimum the number of HTTP requests to perform, basically. So when we have to encrypt a message with a given key, we simply check if the key is available on the local cache. In this way, we don't have to do any HTTP request to Vault. Obviously, we want to have a time-to-based cache because keys might expire because maybe they are deleted on the Vault side, so we want to reflect that on the client side. And as you can see, next slide, please, the performance boost is interesting. Moreover, in the consumer side, we see a performance that almost follows the baseline, obviously with some performance degradation, because now we are performing encryption, which is CPU consuming. And also on the producer side, we are having some interesting results with a message size that grows after, I don't know, 500 bytes. And next slide, please. We will have a quick demo. So basically what I'm doing now is starting one producer that is encrypting the messages and two consumers. One that is decrypting the messages and a third one that simply gets the data from Kafka in a plain way. What I will do is writing some messages. In particular, the things that are coming before the comma are used as Kafka message key. And the things that are after the comma is the Kafka message value. So I'm going to write a couple of messages. As you can see in the second consumer, we are able to read the encrypted data. And instead, in the third console, that is the plain consumer, we are simply seeing some gibberish stuff that is the text encoding of some random byte array. The cool thing to do is that you can see in red, we are showing also the Kafka key version, because this solution supports rotating the key. As you can see, the X Vault encryption key name reflects the Kafka message key value. For the sake of simplicity, we decided to use that. Let's write another message, and then what I'm going to do is to show that we are GDPR compliant. So what I'm going to do now is I'm deleting on the first console the Kafka, the encryption key of the user array. This is simply a wrapper that invokes Vault command line. And I will restart the consumers. What I expect is the first consumer with decryption will simply disregard the messages from user A because the encryption key no longer exists. And it will return only the ones from user B and C. And the third one will try to return everything because it's agnostic. Okay, let's get back to the slides. And as a wrap up, some final remarks. This solution is based on Kafka interceptors, so it is really easy to plug in existing Kafka-based application with Java clients, because we simply need to add the jar containing the interceptor classes to the class path and appropriately configure the clients. It's message format agnostic, so that we are encrypting the message no matter what is the format of the message that is being written. So it could be JSON, strings, numbers, whatever. In particular, with regard to the encryption key, we are storing as the Kafka, in the Kafka headers, the metadata of the key, which is the name and the version in Vault. This is because we might want to also encrypt the Kafka message key and not only the Kafka message payload, which is something we might need to do for regulations. But this is only the starting point. We can further extend this solution. For example, if we are no longer message agnostic and we just want to encrypt a portion of the message, for example, personally identifiable information. So we might need to encrypt just the social security number, content of the message. We might want some extra logic for determining the encryption key to use. In the example, we just use the Kafka message key value. We might want to query some external system in order to determine which is the appropriate key. But moreover, if you are HashiCorp enterprise customers, you have access to the Transform secret engine that is much more powerful than Transit and supports data masking, format preserving encryption, and tokenization that really well fit the GDPR use case. So it might be interesting to demo that in a future webinar. Next slide, please.
Thank you very much, Simone, Ugo, and Narayan. We will open now to questions, and particularly I'm going to see if there are some questions that have been posted in the Q&A section. Thank you very much. So we do not have any questions from the public written in the Q&A section. There might be some questions live from the public, or this is the time to ask them. Very well then. I guess that we can wrap it up. And thank you very much again, Simone Ripamonti, DevOps engineer at Bitrock, Narayan Yengar, product manager, Vault ecosystem at HashiCorp, and Ugo Landini, senior solution engineer at Confluent. They have hosted this webinar, and it's the first time that
there is a question, Alfredo.
Oh, there is a question. Okay. Is it necessary to have an external database to cache the keys? Who wants to answer this?
I can go. So Vault Transit manages the key, and you don't need some external system to have that. It's built in Vault. In the use case that I presented, we cache the key locally on the client side just for a performance improvement, so that we don't have to talk directly to Vault each of the time we need the key. But no external system is needed.
The question was from Daniele Tavolaro. Thank you very much. Any other questions? Thank you very much again to all the speakers and everyone who participated in this webinar. You will receive the recording of the webinar as well as the slide decks that accompanied the presentation of the three speakers. Once again, thank you very much and enjoy the rest of your day. Bye-bye.
Thank you. Bye. Bye.